Hello everyone, welcome to this example video on superposition. So we're going to be attempting the question that's indicated, and the question reads as follows. Determine Vx, that's the voltage across the 15 ohm resistor, due to A, the 12 volt source, and B, the 10 amp source. So we know when attempting superposition problems that we have to deactivate all independent sources except the one in question. So in part A they are saying determine the value of Vx only due to the 12 volt source. So everything else will be deactivated. So I'm going to redraw the circuit. My 12 volt source remains active. Current source gets deactivated whilst my voltage source becomes a short circuit, and this current source is also deactivated. The voltage we're looking for is the Vx at that point. Right. What can we do with the circuit? We can see that there's a connection for simplification purposes. Before we do any calculations, there's a connection of the 20 ohm resistor and the 5 ohm resistor that's parallel. So we can put those together to further simplify the circuit. And we should get a value of 20 in parallel with 5, which will give you 4 ohms. Right, and now that we've determined that simplified circuit, we can then now find the value of Vx. Now it's important to note that passive sign convention states that the current will always flow in a voltage drop direction. So current, which flows from the positive of the circuit around the loop to the negative of the circuit, will flow in a voltage drop direction. So the positive value of the voltage across the 15 ohm resistor will be orientated plus minus, and you can see that that's opposite to the Vx orientation that they're looking for. So immediately I know that the value of Vx will be negative. So I'm going to term this as V, and I know that V will equal to minus Vx. So first I'll solve for V using voltage division. That's going to give me 15 over 15 plus 4 plus 10 all multiplied by 12. And that gives me a value of 6.2 volts. Therefore, Vx, which is minus V, is going to give me negative 6.2 volts. Right. The second part of this then would be to consider part B, which says the voltage Vx due to the 10 amp current source. So we then have to redraw the circuit again. So if I say here due to the 10 amp current source, I'll have to redraw the circuit, and the voltage source now will become a short circuit. That's the Vx. That's 10, that's 2, and that's 20. And we have a current source that was now going to be active. and we have the resistor that sits at that point, and we have the deactivated current source there. So the value of that current source is 10 amps, and we will have the 5 ohm resistor. And again, we're looking for the voltage Vx. So how are we going to find this voltage Vx? Again, what we can do is we can simplify the circuit first. So we can say we've got the current source. I can put the 10 amp and the 20 ohm and the 5 ohm together to give me a 4 ohm resistor. I can then add the 10 and the 2 to give me a 12, and my Vx will be denoted as follows. Right, and now I can calculate the current flowing in the 15 ohm resistor, and then multiply it by the resistance to get the voltage Vx. So the current will give me the opposite resistor, 5 ohm over 5 plus 15 plus 12 multiplied by 10 amps, and that current is going to give me a value of 1.56 amps. Now, as indicated in the first part A, the voltage drop according to passive sign convention will be positive negative, so V would actually equal to 1,56 multiplied by 15, which gives you a value of 23,43 volts. But Vx will equal to minus V, so therefore Vx will give you negative 23, negative 23,43 volts. Alright, thanks for watching this video and enjoy the course.